Moving on with vectors in rectangular coordinates. So vectors have direction I and direction J. Direction I is along the x-axis, and J is along the y-axis. So a component vector or an algebraic vector, you can say it either way, is denoted like this, where you've got these little, not quite parentheses things on either end. And it is representing the vector starting at initial point and going to a terminal point. So in this case, the initial point is 0, 0, and the terminal point is AB. And so that's why the vector is vector AB. And written in component form, it looks like this. And we also call that algebraic form. So position vectors, it says, suppose that vector V has initial point at x1, y1, not necessarily the origin, and terminal point x2, y2. If V is P1, P2, then V is equal to the position vector x sub 2 minus x sub 1, y sub 2 minus y sub 1. So basically, it's just saying that starting at the initial point and going to the terminal point, we represent the vector by subtracting the x values, starting with the terminal point, and subtracting the y values, starting with the terminal point. So example 1 just says, find the position vector from P1, point P1 to P2. Okay, so writing this, let's see, did we? The other way that you can denote a vector, and we'll look at this more in a minute, I think my slides are a little bit out of order, is with AI plus BJ. Okay? Because did I say it there? No. Because I is going along the x-axis and B along the y-axis, and A is the x value and B is the y value, then another way in rectangular form, we would write this as AI plus BJ. In component form, we write it like that. So for example 1, if we want to do this in rectangular form, then we say x sub 2 minus x sub 1 times I plus y sub 2 minus y sub 1 times j. And the reason I'm making those dark is because I and j are vectors in themselves. So we've got 2 minus negative 1, I, plus 7 minus 3, j. So that would be 3i plus 4j. Writing that in component form, the same thing would be like this, 3, 4, with our little pointy parentheses. So here's the slide I was talking about. Representing vectors in rectangular coordinates, we say AI plus BJ. So going from the initial point of 0 to the terminal point of AB, it would be written AI plus BJ. The vector sum AI plus BJ is also called a linear combination of the vector I and j, because we're adding the x component and the y component where it's a linear combination. Then the magnitude is given by the square root of a squared plus b squared. Now we denote the magnitude with these double bars, like this. And the magnitude is the length of the vector. We've already talked about this a little bit. And the length of the vector is found using the Pythagorean theorem. So basically we're just not really anything different here. So the length of the vector, or its magnitude, is found by using the Pythagorean theorem. Example 2 says, sketch this vector and find its magnitude. So if we want to sketch the vector 3i minus 3j, then starting from the origin, this is 3 along the x-axis and negative 3 along the y-axis. So basically the point 3, negative 3. So sketching this vector, it looks like this. Then it asks us to find the magnitude of V. So we're just doing the square root of 3 squared plus negative 3 squared, which is the square root of 18. Simplifying the square root of 18, you get 3 square root of 2. So the magnitude of this vector, or its length, is 3 square root of 2. So again, representing vectors in rectangular form, if the initial point is not at the origin, then you subtract the x values of the terminal point minus the x value of the initial point. And then the y value of the terminal point minus the y value of the initial point. If you want to add or subtract vectors, you add their x values and or add or subtract their x values, add or subtract their y values. For example 3, adding v plus w in rectangular form would be 7 plus 4i, adding the x values, plus 3 plus negative 5j. Seven plus 4 is 11, so it'd be 11i, and then 3 plus negative 5 is negative 2, so 11i minus 2j. V minus w would be 7 minus 4i plus 3 minus negative 5j, which would be 3i plus 8j. And then last, scalar multiplication in terms of I and j we're just multiplying both the x value and the y value by our scalar, by a number. No, Finnick, you're not going out. Okay. Yes, are you just saying hi? Sorry. Okay, so 8v would be 8 times 7i plus 8 times 10j. So that's just 56i plus 80j. And then negative 5v would be negative 5 times 7i plus negative 5 times 10j. That would be negative 35i minus 50j.